Hi everyone, today we're talking about topic 8.2, pH, pOH, of the strong acids and bases. So back in Unit 4, I said you have to memorize the 7 strong acids, and that same thing holds true now. We still have to memorize them. So I'm going to give them to you right now. We have HCl, HBr, and HI. So those are the later halogens. We have nitric acid, which is HNO3, sulfuric acid, which is H2SO4, and this one is special, so I'm going to highlight it so we don't forget about it. We have chloric acid, which is HClO3, and perchloric acid, which is HClO4. Now, by definition, a strong acid completely dissociates in water to form H plus and conjugate base. So let's take this example. Let's take HBr. If I take HBr and I add it to H2O, that means that it's going to completely make H plus, H3O plus, and Br minus. Here's our acid. Water in this case is our base. It's going to make H3O plus, which is our conjugate acid, and Br minus, which is the conjugate base. The important thing to note here is the arrow I used. I specifically used just the right direction arrow because it completely turns into H plus and conjugate base. Now, again, remember, I wrote H3O plus. This is essentially the same thing as H plus because any protons are going to immediately react with water to make H3O plus. And so a strong acid always will do this completely. And so you have, so after dissolving, there is no HBr left. That is, by definition, a strong acid. It will completely split apart the two ions to make H plus and whatever your conjugate base is. Now, I said that there was something important about H2SO4, and that is that it has 2 protons it can give up. The important thing you need to remember here is only the first proton is strong. The second one is weak. So you just need to remember that the first one of H2SO4 is strong, the second one is weak. And so I'm going to actually draw out that equation here so you can see it. H2SO4 plus H2O, that is going to dissociate to make HSO4 minus plus H3O plus. You can still see here that there's a proton. This one is weak. The first one of this is strong. The second thing we need to remember are strong bases. I also said in Unit 4 that we have to remember these. And so these strong bases are the soluble hydroxides. That's your biggest hint right there is hydroxides, OH minus. Now, this isn't all of them. I'm going to give you the list of the ones that are, and those would be LiOH, NaOH, KOH, RbOH, CSOH, CaOH2, SrOH2, and BaOH all of these are these strong bases. If you notice, this first row, these are the alkali metals. And this is, so group 1 on the periodic table. And these are the alkali earth metals. Group 2, and specifically the heavy ones, so everything below calcium. So the first two, Be and Mg, beryllium and magnesium, those are not strong bases. But all of these that I have listed here, you must remember. Because if you're given a problem asking about whether or not something completely dissolves, then this is going to be very important. But remember, the definition here of a strong base is that it completely dissolves in water to give OH minus and whatever metal plus. So I'll write it here in terms of equations. If you have MOH, which is what we have, it's our metal plus an OH, that is going to dissolve completely to make M plus and OH minus. And additionally, if it's the alkali earth metals, the group 2 ones, you get MOH2. That will completely dissolve to, again, get M2 plus and 2 molecules of OH minus. By definition, these will completely dissolve to form these. They do not partially dissolve. So let's think about this back in the context of pH and pOH. So let's say I tell you I dissolve HCl to make 10 milliliters of 0.1 molar HCl, and I ask you, what is the pH? Well, we first need to remember here is that HCl is strong, and so it completely dissolves to make H plus. So what that means is I've taken my HCl, I've dissolved it to make H plus and Cl minus, and since I'm dissolving it, and I'll say here in water, this essentially means I've taken the H plus and water to make H3O plus. And so what if I want to find the pH, all I got to do is pH equals negative log concentration of H plus, which is the same thing as minus log concentration of H3O plus. And since it's strong, I just use that concentration because it's completely dissolved. If it completely dissolves, that should be the concentration. So minus log of 0.1. If you do this math, you'll find that the pH is equal to 1, which means very acidic. Now let's say I want to take it a step further and I ask you, well, what's the concentration of pOH in the solution? Well, we know that 14 equals pH plus pOH, and we know pH. So pOH is just going to equal 14 minus the pH. So equal to 14 minus 1, which equals 13. We don't talk about pOH as often as we do pH. It's the exact reverse of pH. And so if you have and I'll write this here, if pOH is greater than 7, this means acidic because it's the exact reverse of pH. And if pOH is less than 7, this means basic. So we can use these relationships as well as the description that we're given in a problem in order to find things like pH and pOH. We'll have some more practice with this in class, but for now, that's all. Thanks, guys.